Hello everyone! This is going to be section 3.3, Rules of Differentiation, and I'm going to split it up into 3 separate videos. So if you've seen the slate for the week, you'll see that each homework assignment covers a section of 3.3, but it's a lot of information. So you'll notice there's a lot of writing on the board. I want you to find the derivative of f of x equals x cubed minus 2x plus 9. Find the derivative of f of x equals x cubed minus 2x plus 9. And then I also want you to find the slope of the tangent to f of x equals x cubed minus 2x plus 9 at a specific point, x equals 4. So stop the video and do those 2 problems. Okay, so I worked out some of the, I showed some of the work, but you do the limit as h approaches 0, f of x plus h minus the f of x over h. You plug in x plus h and you do all the work. You factor out h and you end up with the limit as h approaches 0, boom, boom, and you end up with 3x squared minus 2. You end up with 3x squared minus 2. Okay, and then when you're trying to find the slope of the tangent at a specific point, that's the f of x, the limit as x approaches 4 of the f of x minus the f of 4 over x minus 4, and you do all that work and you get 46. Okay, so hopefully you started to put a little bit of some of the pieces together, and you recognize that if I were to plug 4 into 3x squared minus 2, you would get 46. Okay, so you found the generic derivative. This represents the slope of a point on the curve. Which point? I don't know. Here we found specifically the slope of the tangent line at x equals 4. So what we could have done was plugged 4 straight into 3x squared minus 2, and you wouldn't have had to have done all of this work. Well, some of you already know the shortcuts, but I'm about to rock your world with finding derivatives. And you're going to say, how come you never told us this to begin with? And it's because sometimes you have to do it the long way before you can do it the shortcut way. Okay, power rule of differentiation is the most powerful rule that there is, and you're going to be using it 9 times out of 10 on the derivative problems that you do. The power rule says that, I'm going to use it, the derivative of x to the n is equal to n times x to the n minus 1. You bring the exponent down in front as a coefficient, and then you multiply that by x, and you decrease the power by 1. So that problem we just did, the f of x is equal to x cubed minus 2x plus 9. F prime, or the derivative with respect to x, the 3 comes down in front, and that becomes 3x squared. This is 2x to the first. The 1 comes down in front. 1 times 2 is 2. Decrease x to the first becomes x to the 0. But anything to the 0 power is 1. So I'm just going to rewrite this here. And then you have this plus 9. Then you have the plus 9. Well, this is the same thing as 9x to the 0 power. Would you agree? So if I bring the 0 in front, 0 times 9 is 0, all done. So the derivative is 3x squared minus 2. So that very first problem that I had you do, where you went through the whole limit as h approaches 0, blah, 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 and you ended up with 3x squared minus 2, well, guess what? There's the power rule. Okay, let's do another one. Let's say that I give you that the function is 2x to the 4th minus 5x squared minus x plus 1. And I want you to find the derivative of this function. So I'm going to show a few more steps than I showed in the last problem. So the derivative of this function with respect to x, also known as f prime of x. This is going to be, bring the 4 in front, multiply that by 2, decrease the power by 1, and you get x cubed. Minus, bring the 2 in front, times the 5 that's already there, decrease the exponent by 1. This is x to the 1st, bring the 1 down in front, decrease the power by 1, you get x to the 0, and then the derivative of a constant is 0, and I'll write that down in a second. So when you are all said and done, this becomes 8x cubed minus 10x minus 1. The derivative of a constant. C is the constant. So they call this the constant rule, or the constant something or other, I don't know what it's called. It doesn't matter. This is why you have some constant with there's no variable. It's the same thing as x to the 0. And when you bring the 0 in front to make it a coefficient, multiply by 0, you get 0, all said and done. Okay. Let's do one where you're asked to find the horizontal tangent. Okay. Derivative represents the slope of the tangent line. The derivative represents the slope of a tangent line. When you find the derivative, like we just did with the power rule, that allows you to find the slope of a tangent line anywhere. If you find it at a specific point, you do the derivative and we can plug in. And I'll do another one of those in a minute. Okay, so let's say you're asked to find where the slope of the tangent is 0. Horizontal. Horizontal. Okay, so I'm going to give you a function. Say y equals x cubed minus 4x squared plus x minus 2. Slope of the tangent, right away, that's the derivative. Right away, that's the derivative. Let's use the power rule. So the derivative with respect to x is 3x squared minus 8x plus 1. Exponent moves down to front, becomes a coefficient, decrease the power by 1. So it went from 3 to 2. Exponent, bring it down in front, multiply it by the negative 4 that was already there, negative 8, decrease the exponent by 1. X to the 1st, bring the exponent down to the front, which is 1, decrease the power by 1, which is 0, x to the 0 is 1. And then the -2, the derivative of a constant is 0. So it has no effect on the problem. Okay, so there's your derivative. That's where you start. The next question is, where is the slope of the tangent horizontal, meaning 0? So here is my generic slope. On the curve, this is x cubed, so it probably looks, who knows? Oh, let's try that again. It probably looks something like that, because it's a cubic function, and it's got all this mess in the middle. So there are, if I've drawn it even halfway correct, there's a tangent, there's a horizontal tangent there and there. Okay, how do I solve this? Well, it's a degree of 2 quadratic formula. So the slope is going to be 0 at opposite of b plus or minus b squared minus 4ac all over 2a. Okay, you can do this without me. I know it's right because I did the problem before I started the video. Okay, so this is what I highly recommend you do. So I plugged this into my calculator and I got that it was 2.5-ish and 0.13, so almost 0. I recommend plug this into your calculator, do a zoom 6, because you were probably doing, tangent lines with differentiation on your calculator probably last chapter. So do a zoom 6, and it does look, something like blah, blah. And you'll see that there are 2 points here and here. And if you look, the x values associated with those 2 points are about 2.5 and 0.13. This looks like it could be a realistic answer. So I recommend plugging into your calculator, making sure that you're getting the, that it looks good. Let's do one more that's a higher power. Let's do y equals x to the 4th minus 7x cubed plus 2x squared plus 15. So same thing, I want to know where is the slope of the tangent line going to be 0? So where is the tangent line 0? Okay, so first thing I'm going to do is find my derivative with the power rule. Okay, and then I want to know where is this 0? So it was the same question before. I want to know where is the tangent horizontal. That's the question. So the derivative is going to tell me where the slope, find the generic slope of the tangent line anywhere on the curve. Horizontal means I specifically want to know where is the slope 0. So I'm going to take my derivative and set it equal to 0. So x is 0. By the way, the degree is 3. You should have 3 answers. The degree is 3. You should have 3 answers. Hold on. I think I made a mistake. This should be... Oh, no, that's right. Minus 21x squared. Yeah. Okay, so quadratic formula. You can do it without me. Obviously, I messed this one up. 441 minus 64 all over 8. And then you would simplify this and get whatever you get. I don't know what it is. Again, I highly recommend that you plug the function into your calculator and whatever 2 answers that you get for this. All right, let's just finish it. Okay, I just did it really fast. Hopefully this is right. Okay, 21 minus that, divided by 8. About 0.2. So I just plugged it into my calculator really quick. This is a fourth power. So the degree, so this is up, end behavior. So it's probably gonna go something like up, and then something like that. It's gonna look like a weird W. All right, that is the beginning of your shortcuts to finding derivatives, so you don't have to use the limit as h approaches 0 of the f of x plus h minus the f of x all over h. You still have to know how to do that, but this should hopefully make your life a bit easier.